The way we are currently managing state is by using properties, usually booleans, to toggle parts of the UI. The problem with this is, the more complex your UI grows, the more booleans and conditionals you'll have, turning everything into a big pile of conditionals that are hard to reason about. Once enough time has passed, you will find it difficult to understand what's going on because there is no way of figuring out the flow of your component without clicking around and checking the code at the same time. State machines help us reduce the amount of conditionals we have in our templates, makes having conflicting states virtually impossible, and even offers a way to actually visualize the flow of our component so we can easily track how and when we end up in a specific state. Looking at this contact form component, we can see conditionals scattered all over the place. We can make some guesses, but we're not really sure when each of them change, or what they even represent, especially when they come in combinations like they do here. Having so many conditionals in so many different places increases the chance of introducing unwanted side effects. One misplaced boolean and everything stops working properly. Even with this example, I actually forgot to add a disable state for the submit button. So as it is, we can submit this form multiple times, which isn't what we want. I'm not even joking, I noticed it before I started recording. It just goes to show how easily we can forget or miss flows and states by using the booleans everywhere approach. So this should be disabled when it's submitting. The first thing we're going to do is go to the xState website and use their visualizer tool to define our state machine. Let's clear out this example so we can start from scratch. Every machine should have an ID and an initial state, which is usually defined as idle. Then we need to define our component states, which in our case they are idle, showing form, submitting, confirming, cancellation, and showing success message. Clicking the update button will show us all the states. The way our component transitions to one state after another is through events. Something needs to happen for our component to change its state. In our example, to go from the idle state to the showing form state, we must click a button that will trigger a show form event. We can define all the events that can occur in a given state under the on key. So this is the event, and to specify the state we want to reach to or transition to, we can use the target key. So this is the event, and this is the state we want to transition to when that event is triggered. Clicking the update button will reflect that in the visualizer. So we have the idle state and then the show form event that will transition us to the showing form state. Let's continue defining the events for the other states. So for the showing form state, if we go back to the actual form, we can see that we can enter the name, the email, message, and then we can either cancel or submit the form. So these are all the events this state can handle. So if we go back, we have on, and then enter name. If we leave out the target key, xState will understand that we want to remain in the same state. So when we enter the name, we'll still be in the showing form state. Now, when the cancel event is sent, we'll transition to the confirming cancellation state. When the submit event is sent, we'll transition to the submitting state. Let's click update. Unexpected identifier, so I missed something somewhere. Oh, right here. Let's try again. So here it is. So we are in the idle state, and then when a show form event is sent, we end up in the showing form state, where we can enter a name, enter an email, message, and then we can either cancel or submit the form. The reason why this is amazingly good is, once we are in a given state, only the events defined in that state will execute. Sending the show form event or any other event will do nothing to our UI, because the only events accepted are the events belonging to the current state of our machine. So currently, only the enter name, email, message, cancel, or submit events are accepted. The submitting state is a bit more special because it should invoke a promise, making the HTTP request to the server that will submit the form. Here's how we invoke a promise. We give it an ID and a source. The source will be later used to execute and return the promise. Then we need to define what should happen when the promise is resolved. And we do that under the undone key. And what should happen when the promise is rejected? We can do that under the onError key. Now when the request is successful and the form is submitted, we should move on to the showing success message state. So target showing success message. When we receive an error, we should just stay on the showing form state. Let's update and see what happens. So now if we click on the show form and we submit the form, we'll reach the submitting state that can be either resolved as successful, that will show the success message, or error that will return us to the showing form state. Moving on, we have the confirm cancellation state. When we end up in the confirm cancellation state, we can either say yes, we want to cancel, or no, to go back to the form. So our only accepted events are yes, and our target is idle, so we'll basically reset the whole flow, or no, and our target will be showing form. Let's click update, and here it is. We go to showing form, and then we click cancel, and then on the confirm cancellation we can either click yes, which will lead us to idle, or no, which will return us to showing the form. And lastly, we have the showing success message state, where we can choose to send another message. So if you go here and fill in this form, we have this button where we can choose to send another message. So we have on new message. We'll go to the showing form state. Update, and here is our flow. Show form, submit, done, showing success message, and then new message to show the form again. Okay, now that we defined all of our states and events, we also need to specify what should happen when some events are sent. For example, when entering the name, we should stay on the showing form state, but we should also assign the name that is being entered. These are defined as actions of an event. And the action that we need to execute is assign name. And of course we need to do the same for the other fields. And of course we have some typos, so we need to assign and assign. Now if we scroll down, we see that we also need to define some actions for the onDone event. So when the submission is successful, we should also clear the form. So we clear the inputs of the form if it's successful. the same thing if the submission is invalid or returns an error, we should set those errors. If we click update, we'll see this reflected on the chart. So we have showing form, and then when entering the name, we trigger the assign name action. Same for the email and the message. When submitting, if the request is successful, we clear the form. If it fails, we set the errors we receive from the server. Our next step is to take this bad boy to VS Code and start writing a component that uses the state machine. I'm just gonna copy everything, go back to VS Code and create a directory called machines and a file called contact form machine. Paste everything in, then make sure we export the machine. And now we should also install xState so we can import this machine right here. Now that xState is installed, let's add the machine import. Before we go any further, we need to define our machine's context. Think of context as being the data your machine operates with. In our case, we have name, email, and message. Currently, we have our actions defined, but we're missing their actual implementations, so let's implement them. To define our actions, we need to pass a second object with an actions key. Our first action is assign name. To update the machine's context, we need to use xState's assign method, which takes in the context assigner, which represents how the values in the current context should be assigned. Let's close the sidebar so we have more space. Okay, so the name will be the value emitted by the event. Let's import the assign from xState rather. And let's also add the implementation for the other fields. So we'll have email and message. Another action we need to add is to clear out the form. So we have clear form. And this should just set all the values to null. So name is null, email is null, message is null. We also have a set errors action right here, but we want to define this because we're not actually sending an HTTP request to a server, but we actually return just a promise with a timeout. So we'll never end up in an error state. Let's also define our submit service. It will just return a faked promise. So services. Here we define all of our invocable services. Submit. And we'll set this to resolve after 1 second. We are finally done setting up our machine. Let's create a new component that will make use of it. So I'll close this terminal, open the sidebar, and create a new component. We'll just grab everything from the other component and paste it here. So we have the styling and everything. Okay, the first thing I'm going to do is clear out everything here. and also the methods. Okay, so let's import our machine. So import Let's close the sidebar again. To handle our machine states and events, we need to use an interpreter. This is provided by xState and we'll set it up as part of our component data. So this will provide a service, so contact service or contact form service, interpret contact form machine. And we also need a property that will hold our current state. Just name that state. It will initially be the initial state of the machine. Let's make sure we import everything we need. So import from xState. And then what we need to do is to actually fire up this service and make sure we track our state. We can do that on the created lifecycle event of this Vue component. This contact form service, and to keep track of our current state, we can use the onTransition method, and we'll just set up the state. And then finally we need to start this machine. Another good practice is to stop the machine on the destroy lifecycle event. So this contact form service stop. Now that we've started our machine, it's time to use it in our template. Let's include our components so we can render it in the browser. So we'll go to AppView and use xState form. And let's put an that will work. So this is the xState version, this is the previous version. Okay, let's close the sidebar. The next thing we are going to do is replace all of our boolean conditionals with actual state checks. We can do that by using the matches method on the state. So we have state matches idle. So this button will be visible only on the idle state. Next up we have show form. We have state matches showing form. So the form will only be visible where we are in the showing form state. Then we have is submitting. This could be replaced with state matches submitting. Show confirm cancellation. We have state matches show and finally we have show success message. Actually I think it's showing success message. Let me check. Confirming cancellation and showing success message. And here is this one. Okay, that looks good. Let's open up our console and click the send us a message button to open the form. It will complain that the openForm method no longer exists. Let's replace it by sending an event to our state machine. The event we need to send is showForm. send show form. If we refresh, it now complains that property or method form is now not defined. So let's remove all these V models. Refresh, and now it shows the form, but it complains that is submitting is not defined. So let's also remove that. Refresh again, and we're good. Let's do the same for all the other method calls. Let's go up. And the first one is submit. So instead of submitting, we'll just send a new event called submit. Go down. Instead of canceling this submission, we can send an event called cancel. Instead of canceling cancellation, we can send cancel or no. And instead of confirming cancellation, we can actually send yes. And finally, we need to replace send another message by sending a new message event. And I think we're done with the events. Yes. Let's refresh. Send us a message, cancel. No, I want to go back. Cancel, yes, cancel. So everything seems to be working so far, except our form is hidden when we click the submit button. The reason for that is we need to include one more state when our form is visible. So it's showing form and submitting. Now that we've reached this point, showing form no longer makes much sense, as the form is also shown when we are submitting it. A better name would be opened form. Let's make the changes so it reflects our new logic. So opened form. And we also need to update the machine. And instead of show form, we should have open form. Let's do the same here, where we are sending the show form event. Save and refresh. And now when we are submitting, the form is still visible. The next step is to make sure our context is updated whenever the user fills in the form. Let's add a console log so we can see how our state looks. We can go to this on transition, and after we're setting the state, we add a console. So whenever the state changes, we'll output it to the console. Nothing changed. So we need to send our enter name event. We can do that on input. Since this event will also send a value, we need to type it in as an object. It will receive the type of the event, which is enter name, and the value, which we can grab from the actual input event. Okay, that looks right. So when we type in the name, the state will change, as you can see in the console. If we open up the state object, go to context, we'll see that our name is now this gibberish. Let's do the same for the other inputs. I'll just grab this, and instead of enter name, we'll have enter email. And then we'll have enter message. Let's test it out. And here it is. One thing we need to make sure is that our inputs stay filled, because now if we hit cancel and then we want to go back, the inputs are getting emptied. To make sure we keep the value, we need to define it here. So we'll do value equals state context name, and the same for all the other fields. We have state context email, and then state context message. So now if we refresh, fill the form, say we want to cancel, and then we want to go back, the fields are still filled in. Hit the submit button, send another message. The inputs are cleared because in our machine we have this clear form after showing the success message. And that's it. Remember that you can always take your xState machine and throw it in the visualizer so you can see the actual flow of your component. State machines allow you to be specific and actionable on what the state of your UI is and what possible states it can be next. Using the visualizer, you will reduce the time spent figuring out how everything works or should work. Another benefit is that xState is framework agnostic. In our example, we've used VueJS, but we could easily have used the same machine with any other framework. React, Angular, Svelte, you name it. xState and state machines are amazing. You should use them, especially if you're dealing with complex UIs. Bye.